Now let's work some more with Venn diagrams. First of all, let's look at the union of A, B, and C. I'm going to draw a diagram. Circle for A, circle for B, circle for C. Now we want to shade the union of A, B, and C. When you see A union B union C, this is the same as if I unioned A and B together, took that result and unioned it with C, or if I put B and C together using the union operation first, and then combine them with A using the union. In other words, the union operation is associative. If I have 3, I can start with any 2. It's also commutative, meaning I can change the order. So, when we see the union of A, B, and C like this, this means that we need to be looking at elements that are in at least one of these sets. Okay, so what will we shade? Well, everything in circle A will be shaded, but so will anything that is included in B or C. So everything that's in at least one of the circles will be shaded. And the parentheses around A and B are not needed, as long as we don't mix unions and intersections together. Let's do another one. Let's look at the intersection of A, B, and C. So A intersect B, intersect C. Once again, when you see this, this means we could intersect A and B, take that result and intersect it with C, or we can start with B intersect C, intersect that with A. And so this means that the elements have to be in all 3 sets. Intersection means it's in all of the sets. So I draw my sets. Here's A, here is B, here is C. Now I want to shade. What elements are going to be in all 3 sets? The only ones that will be in all 3 are the ones in this little area right here. Does that make sense? Remember, your union means it's in at least one of the sets. Your intersection means it is in all of the sets. Let's move on. We want to look at A union of B complement, parentheses around that, and then we're going to intersect it with C. I draw my diagram. Now, when I see something complicated like this, if I see intersect C, that's where I'll start. This means that the elements have to be in C, and then they also have to be in that other set that's combined with parentheses. So, when I start, that means the only place I'm going to look is C. I'm not even going to worry about the rest, because I know whatever's going on with the rest, it's not going to ultimately be shaded. The ones that are ultimately shaded are going to be elements that are in C. Now, they also have to be in A or in B complement. Which means not set B. Okay? It's got to be an A or in B complement. Okay, well, what elements are going to put it in A? Okay, so these guys will be in A, right? A. But they could also be in B complement. Now if I look right here, these are not in B complement, nor are they in A. Therefore, I cannot include this little area. But what about here? These ones right here are in B complement. Therefore, this area has to get shaded. So here is, this green area is the desired set. Okay, let's move on. Let me get my black pen back. Let's consider a group of students. 30 of them are enrolled in a math course, and 35 are enrolled in an English course. 13 students are enrolled in both English and math. Okay, so let's determine what our sets are going to represent. Let's let E be that the student is enrolled in English. And let's let M represent the set of students that are enrolled in math. And let's draw ourselves a Venn diagram. Math, English. Okay, so let's fill in what we can. What do we know for certain? We know that 13 of the students are enrolled in both English and math. So where in our Venn diagram would those students be? Well, they'd be right here in the overlapping area between set M and set E. Now, how many students are in math? Altogether, there are 30 in math, but some of them are already in. If I were to put 30 right here, that puts me with a total of 43 students in math, which would not be correct. So instead, what we want to do is we need to take the 30, subtract the 13 that are already there, and that gives me 17. That's how many are in math, but not English. Now, how many students are in English altogether? 35. Now let's subtract the 13 that are already there, and that is going to give me 22. So I have 22 right here. Sometimes you'll have enough information. If you had some information about the universal set, the total number of students under consideration, you would be able to fill in something for this outside number that would be right here. That would be the, I better not write that, that looks like a 0. But right here, this would be the students in this area that are in neither English nor math, but we do not know the total number of students under consideration, so we don't have enough information to write that number down. However, we don't need it to answer our question. How many students are enrolled in math or English? Okay, don't think of this or as being an exclusive or. This is an or, this or means that it's possible to be in both. So when you see math or English, you should think to yourself math or English or possibly both. In other words, what students would answer yes to the question, the yes/no question, are you enrolled in math or English? If they answer yes, they should be in this set. And so that's going to be the union, the number in the union. So that'll be 52 students. Okay. Now I've used a notation here that I haven't yet introduced to you. This means the number of students in the union. We use that lowercase n. It's a function. We put the input in parentheses, so that'll be in the set. So just as you've seen f of x in algebra, here we have n of a. It means the number of elements in A. And there's something that we could notice if we went back to the example that we just did. The number of elements in the union, and this should be an equal sign right here. Sorry, these do not always come through with this program like they should. The number in the union is equal to the number in A plus the number in B minus, this one is indeed a minus, the number in the intersection. Okay, so if we go back to what we had a moment ago, remember we had, let's just do it right here. You could actually do this without a Venn diagram if you knew that addition formula. The number in M union E is equal to the number in M plus the number in E minus the number in the intersection. What we really need to do is we need to subtract the ones in the intersection because they are getting counted twice. They're members of M and also E. Therefore, they're getting counted twice. We do not want to count them twice, so we have to subtract it. So how many are in math? 30. How many are in English? 35. How many are in both? 13. So this gives me 65 minus 13, which is 52, and that's the same answer that we did before looking at the Venn diagram. Should point out something else on this. If you were to solve that formula for the number in the intersection, okay, so that means you would add n of A intersect B to both sides of your equation, which would give us this. Now what would we do? We would subtract the number in the union from both sides. This is an alternative way of writing the exact same formula. It's not as intuitive. This formula is a little more intuitive because what we're doing is we're thinking of adding the number in A, adding the number in B, and subtracting the ones who are counted twice. So, but sometimes this form is helpful. Remember, if you have any three of these four quantities, you can use this to solve for the fourth. Also, if A and B are disjoint, meaning they don't overlap, then the number of the union will be obtained just by adding the two of them together. In other words, the number in the intersection will be 0. And if we had disjoint sets, the way we would indicate that on our Venn diagram is by circles that do not overlap, like this. And so here the number in the intersection is 0. We could also say that the intersection itself is the empty set. In that case, you would just add the numbers in A and B to get the total in the union. Let's do another example. Suppose we have 100 students that are surveyed to determine if they'd watch ESPN or Fox Sports. Results showed that 65 watched ESPN, 55 watched Fox, 30 watched neither. Let's draw ourselves a Venn diagram. Okay, and let's let E represent the people that watched ESPN, and let's let F represent those that watched Fox Sports. And so when I draw my Venn diagram, it'll look like this. If I look at this, we know that 30 people watch neither. So we've got 30 here on the outside. We know that we have 100 total. Sometimes you'll see that written on the outside of the Venn diagram like this. Okay. If I take that 100 and subtract the 30, that gives me 70. What will that be? That'll be the number that are in the union. In other words, the number that are somewhere in one or both of these circles. Okay, so there's got to be 70 in there. Now, I know that if I have 70 total, let's subtract the ones that are in set E. Okay, that'll be 65. Okay, if you think of covering up everything in E, what's left? 5. In other words, if the E circle right here has 65 in it, and I know there's 70 total in this red outlined area, that means I've got to have 5 over here, right? Okay. Similarly, if I take the 70, subtract the 55 that I know are in set F, that gives me 15, which has to be here. Okay. Now, what else do I know? I know that there are 70 altogether in the union. So, if I take the 70, subtract the 15, subtract the 5, that gives me 70 minus 20, which is 50. That tells me how many are here in the middle. Now, before you start answering the questions, check your Venn diagram against the words of the original problem. First of all, check that we have 100 students. Okay, we have 15 plus 50 plus 5 plus 30. We're just trying to make sure everything matches up. That's 65, and 5 is 70, plus 30 is 100. Okay, so that's good. So now check how many are in E. 15 plus 50, which is 65, right? Okay, that's what it's supposed to be. How many are in F? 50 plus 5. I'm just adding up the two numbers that are in circle F. That gives me 55. That's what it should be. So that tells me that everything checks out and that my Venn diagram is correct and matches the original problem. So now we can answer the questions. How many people watched ESPN but not Fox? Well, how do we write that in set notation? They watched ESPN, so that means they are in E. However, they are not Fox watchers, so F complement. What portion of my Venn diagram applies to that? Well, they have to be in E but not F, so that would be 15. How many people watched Fox but not ESPN? So this time they are Fox watchers, but they are non-ESPN watchers. So F intersect E complement. So they're in F, but they're not in E, so that'll be 5. How many people watched both? We can get that right off our diagram. E intersect F. 50 people watched both. Okay, let's move on. Let's suppose that I want to purchase a car from J. Austin Motors. We have some information here about how many cars have windows, moonroofs, and CD changers and various combinations of those. And we have some questions to answer. before we even try to answer the questions, we should draw a Venn diagram. So before we draw a Venn diagram, we have to define our sets. So let's let W be the set of cars with power windows. And let's let C be the set of cars with CD changers. And let's let M be the set of cars with moonroofs. And we want to use the given information to fill out this Venn diagram as completely as possible. Make sure when you draw your Venn diagram you leave yourself enough room, make your circles overlap by enough that you have room to put a number in each of the spaces. In other words, make sure you leave yourselves a pretty good size intersection between the circles. Make your life easier as you're filling it out. Okay, you want to start with whatever the easiest thing is first. Okay, what's the easiest here? We want something that we can put immediately into the Venn diagram without doing any work. Let's start at the beginning. Well, 89 cars have power windows, but if I look at the power windows circle, it's divided into 4 sections. And I don't have enough information in that phrase to answer it, so we're going to move on. Actually, if we go toward the end here, 21 cars have base models with no features, so where's that going to go? Well, that's going to go on the outside. What else is easy? 12 have all 3 features, so that goes here. That's also easy. Okay, now let's move to the ones that only list 2 of the characteristics. Okay, so we're basically working from the end back to the beginning. 53 have a moonroof and power windows. Okay, so moonroof and power windows, where does that put me? That puts me here, right? Moonroof and power windows. And we know that there are 53 of those, but 12 of them are already in there, so we need to do a little subtraction. And that gives me 41, which is going to go here. Does that make sense? So now I have 53 total in that area that overlaps between the power windows and the moonroofs. Okay, let's move on to the next 2-feature phrase. 40 have a moonroof and a CD changer. So moonroof and CD changer, but that 40 again already includes the 12. So subtract those and you're going to get 40 minus the 12 will give me 28, which is here. And so now that overlapping area between moonroof and CD changer includes 28 of them. Okay, now 32 of them have power windows and CD changers. So 32, but I have to subtract the 12 that are already there, and so that gives me 20, which will go here. So now we've made some progress. Okay, now we go back to the beginning. 89 have power windows. So if I take that 89 that have power windows, now if you look at your little circle for your power windows, see before we couldn't fill in any of these because we had 4 areas and we only had 1 number. But now we know the total number in the circle. 3 of the areas are filled in, so we can use subtraction to obtain the number that's missing. So we take the 89, subtract the 41, minus the 12, minus the 20, and you should get 16. So that goes here. Now we do the same thing for the moonroofs. We know that the total moonroof circle has to add up to 100. So take 100, subtract the numbers that are already there. So that means the 41 and the 12 and the 28. And that should give you 19 in the moonroof circle. Actually 19 in this outside remaining part of the moonroof circle. And now we move on to the CD changers. Looks like 74 have CD changers. To take 74, subtract the areas that are already there, so 20 and the 12 and the 28, and you should get 14 right here. Once everything is filled in, then you're ready to answer the questions. Actually, before you answer the questions, you should check this Venn diagram against the original problem like we did before. Just double check that the right total number have windows, moonroofs, CD changers. You can use your calculator. Double check that all the circles add up correctly and all the little parts add up correctly and that everything matches. And so now we answer the questions. Okay. A, I strongly dislike power windows. One more thing to break. I like being able to turn the crank myself. I do like a moonroof and a CD changer. Okay, how many cars do I have to choose from? So that means I do not want the windows, but I would like a moonroof and also a CD changer. So what would that be? That looks to me like 28 cars. Which 28? Right here. These are the ones that have a moonroof and a CD changer but do not have power windows. Okay. Now, how do we get the total number of cars on the lot? Simply add up all the numbers in the Venn diagram. So we would take the 16 and the 41 and the 20 and the 12. Just try to be systematic. Then I have the 19 and the 28 and the 14 and the 21. If I added all this up right, I should get 171. Please do it and make sure you agree. Well, I hope this helped you to understand Venn diagrams a little bit better. Good luck, and I'll see you next time.